In this video, I cover a study requested by NASA and carried out by Johns Hopkins Applied Physics Laboratory on Lunar Infrastructure Technologies, or LIT. Johns Hopkins is part of a group of over 3,500 developers working on lunar surface technologies. NASA wants to know what technologies will help with operating a nuclear reactor to power resource extraction and processing to enable a sustainable base on the Moon. NASA is keen for its grants to catalyze a chain reaction of technology development to build the entire pipeline needed for commercial exploitation and development of the Moon. Johns Hopkins assembled a study team to assess how credible it is for NASA, assuming it's willing to accept higher risk missions and payloads, to set an ambitious timeline for lunar exploration and settlement that leverages existing and near-term technologies. In this video, I'm going to focus on the minimum viable infrastructure concept the study introduces. So, let's look at what the study had to say. Minimum viable infrastructure. The study suggests a rapidly executable set of missions to enable continuous operations on the Moon, with the possibility of extending the concept to Mars. The LIT study team prioritizes existing or near-term technologies with the goal of rapid deployment of essential lunar infrastructure needed to commercialize lunar surfaces. This reminds me of DARPA's Lunar 10 study, which also had the goal of enabling lunar commercial surfaces. DARPA last week released their field guide to jumpstarting the lunar economy. It's a 260-page document with 130 authors, which I will look at in detail soon. But let's get back to the Johns Hopkins study. What's the plan? The study suggests a single lunar surface region that should be set up immediately. They suggest delivering permanent infrastructure to the Moon by 2028, that's just over 2 years away, and completing the minimal viable infrastructure needed just a year later in 2029. Included in the minimum viable infrastructure is power distribution at infrastructure scale, communications and positioning, navigation and timing, or PNT, surface logistics, which likely means rovers, for inspection and connection of elements, landing of a fission surface power system, that's a nuclear reactor which will be at least 100 kilowatts of power, but could be more, and the start of commercial services, for instance, purchasing of power, communications and navigation services. Later on, it could mean fees for landing on launch pads and purchasing of locally produced materials and resources. This minimum infrastructure then supports and enables more complex operations, such as ISRU, that is excavating and processing lunar materials for resources, such as oxygen, water and propellant initially. In addition, this minimum infrastructure supports construction and habitat activities and operations. The study mentions site preparation, interoperable systems, and continuous operational presence, similar to what happens in low Earth orbit with the International Space Station. Strategic shift. The study team considers the rapid deployment of minimal infrastructure as a strategic shift. Rapidly building out a single base on the Moon by 2029 creates a demand signal to space startups and commercial companies. The base is an interoperable platform for many companies to operate together on the lunar surface. Today, we are already seeing space startups with lunar technologies partnering to work together on systems, but that's a topic for another video. To achieve a fixed launch cadence, payloads and landers will use plug-and-play interfaces. A common standard allows developers to build flight-ready systems without waiting years for vendor specifications. This gives the campaign, as the LIT team calls it, the flexibility to backfill or reprioritize payloads. From the graphic, we can see the base build-out schedule. The LIT precursor mission lifts off in 2026, that's next year, with the purpose of securing the site. Later in 2026, LIT-1 lands power systems that can survive the lunar night. In 2027, the LIT-2 mission places minimal viable infrastructure on the lunar surface. In 2028, LIT-3 establishes continuous operational power to the base. And in 2029, a nuclear reactor is deployed and integrated into the power grid. This campaign helps commercial companies and startups by providing regular awards and quick wins. Stable funding is required with regular opportunities issued by NASA as the campaign progresses over time. Sequencing of payloads to the lunar base can be adjusted to meet NASA's strategic objectives and the evolving capabilities of space startups. Lit takes more shots on goal, and to continue with the sporting metaphors, puts more players on the field. Each startup, thanks to interoperable systems, can work together to achieve their objectives. Objectives and opportunities. To achieve plug-and-play commercial activities on the Moon, a number of sequential high-level objectives need to be defined and implemented. These include enable co-location of multiple assets, deploy expandable systems including persistent network communications, establish scalable commercial power distribution and lunar survival across multiple platforms, landers, rovers, etc. You can't run a lunar economy if you can only operate 50% of the time. And provide systems for surface exploration to support surveying, logistics and mobility to connect to infrastructure. In addition, add explicit commercial services, such as power metering for example, in a low-cost way to unlock economic activity from the start and begin real commercial transactions as soon as possible. Final thoughts. The lit concept in a nutshell is for a high-cadence rapid setup of a base in a single region of the Moon. Within a few years, all the essential infrastructure to support continuous operation on the Moon would be established. Using interoperable systems with stable funding drives the demand signal to space startups and established companies to build, design and deploy commercial systems on the Moon quickly. If NASA was interested in following this plan, it would rapidly pick a prime location for lunar operations with a mission to secure the site in 2026. Followed by missions to build out power, communications, and mobility systems to allow human presence on a continuous basis. Commercial services would include power, communications, positioning and navigation, mobility, and habitation. Once the minimal lunar infrastructure was established, it would support more complex operations, such as lunar harvesting, mining, and processing of materials. Large-scale surface or subsurface construction projects using heavier and more capable equipment would support landing and launch pads, unpressurized shelters, and underground facilities, such as solar storm shelters and buried or semi-buried habitats. The study report ends with a clear message. Action now will ignite a new era of lunar innovation on stable ground for expansion. Rather than ceding leadership, we must act now to define it ourselves." Unquote. Is it time for NASA to land and secure a site on the Moon? What do you think of this rapid, high-cadence plan to establish a base at a single location on the Moon and to set up all essential infrastructure before 2030? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.